Okay, so today you are going to complete doodle notes on endothermic and exothermic reactions, and this is going to prepare you for our notes on Monday. So this is set up in the style of Cornell notes, which is where you have questions in your margin on the left, and you have information for your notes on the right hand side. The information for your notes should help answer the questions on the left hand side. And because these are Cornell notes, you will also be doing a summary at the end, which is part of the assessment piece at the end of this. Anyways, to help you with this, so if you notice, of course, you have blanks to fill in. What I did is, I'm going to get my little laser pointer here. Come on. Okay, so what I did is I put boxes around the words that go in those spots so that you would know what goes where. So our essential question for this is, how is energy transferred and used during a chemical reaction or process? Now, because this is called thermochemistry and because we have the word therm or the base therm in our title, we're obviously going to be talking about heat. So some vocabulary, and this is mainly review because you should already know this. Temperature is a measure of the kinetic energy, so that means it's measuring how fast molecules are moving. The faster they move, the more movement, the higher the temperature. The slower they're moving, the lower the temperature. And then reactants and products you should definitely know. So reactants are before the reaction occurs. The arrow indicates that a reaction has occurred. The products is what that reaction produce. So they're after the reaction occurs. If you need a way to remember that, you can always remember RAP, reaction, arrow, product. So topic question number one, and your topic questions are on the left-hand side. Remember I said that your questions in the left should be able to be answered by the information in the main part of your notes. All right. So topic question number one, how is heat involved in chemical reactions and physical processes? So if in order for the reaction or process to happen, so in order for this reaction to happen or the process to happen, if the energy needs to be absorbed by the system, okay, so we're going to be talking about system and surroundings. We'll talk about this on Monday as well. In this, what system and surroundings is, system is where the reaction is occurring. So the system is right here. The reaction is occurring inside this flask. So this is the system. Everything outside of that, that's called the surroundings. So what is happening is energy is having to be absorbed from the surroundings into this reaction. So what that means is, since we're absorbing the energy is going to be one of our reactants. So we have our actual reactants, so what the chemicals are, the substances are, plus we have to add that energy, and usually that energy is in the form of heat. Then we get our products. If, on the other hand, if the reaction or process happens and it releases energy from the reaction. So here we have our system and our surroundings again. Once again, system is where the reaction is occurring. So this reaction is occurring once again inside the Erlenmeyer flask. But if you notice, it is releasing the heat to the system. So the heat is it's releasing heat to the surroundings. The heat is leaving the system. So we're giving heat off. Because we give heat off, heat is a product because that is something that we have given off. Okay. Topic question number two, what are those two types of reactions called? Well, one of them is called endothermic. Endo means inside, therm, of course, means heat. So inside heat. So in an endothermic reaction, heat goes into the system. Okay, so that's where we're absorbing heat into the system. So inside heat, heat's got to flow into the system. That's endothermic. Way you can remember what endothermic is, think of endoskeleton. Okay, endoskeleton, that's inside of our body. That's our skeleton inside of our body. The other one is called exothermic, which is outside heat. So in an exothermic process, heat's flowing outside. So heat is going to leave the system and it's going to go into the surroundings. To help you remember that, you can think about exoskeleton like on a crab. Because remember, their shells are really, really, really tough, and it protects that nice, yummy meat inside, the kind that you go get at Joe's Crab Shack or Red Lobster. Topic question number three, what is happening on a particle level? So for an endothermic reaction, what's happening on a particle level, which means what's happening in the molecules, where we can't actually see it. For an endothermic reaction, it is taking us putting in a lot of heat in order to break the bonds. So we're adding in a lot of heat to break the bonds. We're not adding in a lot of heat to make the temperature rise. It's not about making the movement of the particles go faster. It's about breaking the bonds. Because remember, there's bonds between your atoms. Those bonds have to be broken because in a reaction, you have new products being formed, but it's being formed by these same atoms, the same substance over here. They've just been rearranged. But in order for it to be rearranged, those bonds have got to be broken first. So it takes a lot of energy to break those bonds, and then you end up getting your products. So in that case, the temperature of the reaction actually drops. In an exothermic reaction, lots of energy is going to be released once the new bonds are formed. So in other words, it doesn't take a lot of energy to break the bonds. Like you're always going to have a little bit of energy always involved. But it depends on, is it really like, does it take a whole bunch because you have to have the energy to break the bond, or is it just a normal amount? So there's always a little bit of energy. Energy is always what is used to break the bond. But when those bonds are broken and then your new bonds are formed, it releases a lot of the energy, a lot of the heat. And that does cause the motion of the particles to speed up. So therefore, the temperature of the reaction is going to increase. So how does this look on a graph? And on Monday, we'll be looking more closely at these graphs because you will be able to read a graph, tell me what the amount of energy is, which we'll call enthalpy, be able to label your graph and everything. So the graph is simple. This is called a reaction graph. So on the x-axis is your reaction, so basically time. And then the amount of energy is on the y-axis. So for endothermic reaction, remember that you have to take in heat in order to break the bonds. So if you notice, we have to take in a lot of heat. So as we're taking in that heat, and then we end up doing that reaction, we get our products, because we had to take in so much heat, our products will have a higher amount of energy than our reactants because we had to take in energy. For exothermic reactions, the opposite is true. So same type of graph, still reaction on the X, energy on the Y, but this time, remember that we give off heat. So when the products, once the reaction occurs, we release a lot of heat. So because we're releasing that heat, which means we're releasing that energy, our products end up with very little energy. So they end up with less energy than our reactants. Okay, and so exothermic, and this is part I forgot to touch on with endothermic. Endothermic is going to feel cold because what's happening is it's taking in, like if you were to put it in your hand, okay, if you were to put this Erlenmeyer flask in your hand, it would be taking the heat from your hand into that reaction, which means your hand would feel cold because your hand's losing heat. For exothermic reactions, if you were to put this Erlenmeyer flask in your hand, because it is given off heat, it is going to feel hot. Topic question number 5. What are some real life examples? Well, some real life examples are cold packs. Okay, instant cold packs. You sprain your ankle, your, sports, whatever, or you're hiking, anything like that. So that instant cold pack, that reaction is an endothermic reaction because it feels cold. Melting an ice cube in your hand, because what's happening is the heat from your hand is going into the ice cube, which causes the ice cube to melt. So the process we're talking about is the melting of the ice cube. And so that is taking in heat to melt it. The cooking process itself is also endothermic because remember, it takes a lot of heat in order to make food. If you think about menthol cough drops, sorry, they're called Halls, the menthol cough drops, if you put those in your mouth, they feel cool, right? Like they kind of like cool off your mouth. Or think about mouthwash, minty mouthwash. That is because there's an endothermic chemical in there. And then photosynthesis is also an endothermic reaction because it takes the sunlight in order for photosynthesis to occur. Without the sunlight, you can't have photosynthesis. And that sunlight is where the heat energy comes from. For exothermic reactions, remember these are the ones that are going to feel hot or they're going to release energy. Fireworks is a good example. the hand warmers. So those of y'all that are hunters or anyone who goes hiking, during winter months, or you do camping in winter months, hand warmers, a fire, condensing, whenever. So what you have is you have water vapor in the air, and then it's going to condense into a liquid on the outside of a cold glass, because we are losing the heat. That water vapor is releasing energy because it's got to cool down. So it's releasing the energy. So that is also exothermic. Same thing with freezing water. So turning water into ice is also exothermic, because you start with liquid and you got to go to solid. Well, in order to go from liquid to solid, you have to lose the heat, because if you're going liquid to solid, that means you're getting colder. So that means you're letting heat off. So that's also exothermic, as is burning rocket fuel. All right, so on the bottom part, after your topic question 5, you have a sum it up section. This is where 50% of your grade for this comes from. So if you notice, the first thing it says is label the parts of the reaction using the words from the word bank, and it gives you yield sign, products, reactants, and heat. If you look over to the right, you see you have the equation for photosynthesis. And so you need to label the parts of that equation where all of the arrows are. So if you look underneath, there is an arrow for the left-hand side. You look underneath, there's an arrow for the right-hand side. And then you have a curved arrow pointing towards the sun and a curved arrow pointing to the arrow that's facing to the right side. Then the next section, you have 1, 2, 3, 4, 5, 6 scenarios, and you need to tell me whether those are going to be endothermic or exothermic reactions or processes. And all you need to write in that blank is either endo or exo. Okay, so use what you learned here, use your examples that you have. And then last but not least, your $2 summary. So you have a $2 summary, which means you have to write a summary in 20 words or less. Any more, we take off points. Okay, so 20 words or less summary of what these notes were about. So your notes should contain something about the heat and reaction. So maybe like what an exothermic and an endothermic reaction is. And you want to sum it up in 20 words or less. You can have, that's about 2 sentences really. 2 sentences and you can have this summed up. All right, but it needs to be summed up about the lesson. What is endothermic? What is exothermic? How is heat moved in chemical reactions? If you don't have enough room to write it in that little bitty space there, you can write it on the very back of your page. Just make sure you write me a note where it says $2 summary. Hey, summary's on the back. I have included a link, so a URL to the links on one of the questions here. I've included the URL to the links that's there for the quick watch. If you would like to go watch those videos, it's showing you some very quick reactions and showing you how it's cold or it's hot, because it's using thermal imaging, and it can show you that. Last but not least, in that bottom right hand corner, it says, how are you feeling about the basics of endothermic and exothermic reactions? And it asks you to circle one. So this is just kind of for me to know, how are you doing? So I got this, I think I have it, or I don't get it at all. So make sure you fill that out. When you are done, you will turn these in up at the front. Coloring, if you would like to color the pictures, I will give you 10 points of extra credit on your thermochemistry test for coloring. However, do not color everything the same. So you need to take time with coloring. Now, it is only extra credit. So it is more important to get these turned in than it is to color. So it's only extra credit. You don't have to if you don't want to. But anyway, so there is an offering there. If you do not finish in class today, because maybe you were taking your CBA or you just didn't finish for whatever reason, you need to have these ready to go on Monday, because they need to be turned in on Monday. That is when they will be put into the grade book.